All right, so we kind of ran out of time. I have your tests, quizzes, whatever. They're 36-point quizzes, and for the most part, they're pretty good. But I will go over those at the end of class if we have time. I don't think it's a huge hurry to go back through them because we'll have those questions on our test on Friday. But we can always go over on Thursday, and I really want to make sure I get in this stuff. So it's really a fairly short test from the standpoint of it's going to be area and volume. So, law of cosines, law of sines, and area, and then de Moivre's theorem and complex numbers. And most of that complex number stuff I think you knew, with the exception of, or at least it fit with what you knew from vectors, with the exception of multiplying. Complex numbers that are in trig form, remember, you already know how to multiply them when they're not in trig form, right? But multiplying them in trig form, what is the rule? Multiply the absolute values, right? And then what? Add the two angles, and then when you leave your answer, you always leave it to where the angles are in between 0 and 360 for a matter of good form. And then to divide them, to divide a complex number by another complex number, what's our rule? So the one that's on the top goes on the top to divide. So absolute value of the first one was 3, so 3 over 6. And then subtract the angles, right, in that form. And that's if they're in trig form. If they're not in trig form, then it boils down to rationalizing, right? That's how you divide when they're not in trig form. You already know how to do that, or you should. And just be careful when you do that in your FOIL. Also, by the way, every year I see people, they multiply by the conjugate, and for some reason they just go, oh yeah, that all goes away. But if you multiply it out, it doesn't go away. I mean, the OI in the FOIL does. So when you FOIL it out, that was the goal of it, to make the middle terms go away, but you still end up with the 25 and the negative 69 squared, which combine together, and then you put it in A plus BI form. But if it's the new rule for trig form, remember to divide those values to get a half and subtract those angles to get negative 25. And then remember the shortcut? Instead of writing cosine theta plus I sine theta, you can write CIS theta. And then remember, again, always write your angle between. Well, it's Tuesday, we got to be a little more chipper, right? Between 0 and 360. So add a 360 if you need to, or subtract a bunch of 360s. A lot of times you'll see with de Moivre's theorem today, these angles start getting bigger and bigger and bigger, and that you might have to subtract 360 4 or 5 times to get it in between 0 and 360, but you want to do that, okay? Now, de Moivre's theorem is what we started talking about yesterday, and we kind of got hung up on time. So we kind of started to develop it by showing how you could multiply an angle by itself, a complex number by itself, but the bottom line on de Moivre's theorem is what? If I'm raising a complex number to a power, and by the way, I don't even have to name it. Like, I could have something like, what is this example? 3. Like, I don't have to say, hey, if z is that, what is z to the 4th? I could just say, what is that to the 4th power? I don't have to do this junk right here. That's just what the book and sometimes people do. So if I just said to the 4th, you need to think, hey, this is a complex number in trig form raised to the 4th power. And what does your rule tell you? We just got to that yesterday. Take the 3 to the 4th. Did we get to this yesterday? I thought we did. Yeah. So take the 3 to the 4th, and then what do you do with the angle? Multiply them by 4. So that's going to give me 81 on the outside. It's going to give me 80 on the inside. And you're welcome to leave that like this. But you will see in about 15 minutes after going through a few more of these, when we get to doing roots of these as opposed to powers, like if I start doing the 4th root of that, you end up getting situations where there's a lot of answers. Like for a 4th root, there are 4 answers. For a 10th root, there would be 10 answers. And you're going to get really sick and tired of writing cosine blah plus I sine blah, cosine blah plus I sine blah. So it's really nice to be able to just write CIS angle to stand for that whole thing. But that is your choice. If you like writing cosine theta plus I sine theta over and over again, knock yourself out. All right? Now, that works great if I'm in trig form. Are y'all with me? What if I'm not in trig form? and I give you something like 2 minus 2i and say, take that and raise it to the 6th. Or I don't even name it like z. I just say, what is that to the 6th? Well, if I do that, that's kind of a pain to write this out 6 times and start foiling like a madman or mad woman. It's not that fun. So what I can do, though, is change these complex numbers, change that back into trig form. And what do I need for trig form? 2 things. I need absolute value, which is like the magnitude. So the absolute value would be 2 squared, negative 2 squared. Remember, we don't square the I, right? So 4 and 4 added together, square rooted. So square root of 8 would be the absolute value. That goes on the outside. And then how do I deal with the angle? Inverse tangent of the y over the x, which ends up giving me inverse tangent of negative 1, which is negative 45, right? And do I add 180? Why not? Because the lead term is positive, so that means it's over there in either the first or the fourth, which is okay. So I take that negative 45 and make it the angle, and look, now I have it in trig form. So now to raise this to the 6th power, which is what it's asking me to do right here, right? How do I raise that to the 6th? Now, if you have a calculator, just do root 8 to the 6th. But do you all know how to do root 8 to the 6th power? Let's think about it. Say it again.
Like, because since it's an even like exponent, and you can just like half it, because the root of the 8 times another root of the 8 is just 8.
That's true. She's saying, because I think this is what you're saying, because I basically have 6 of these, right? Each pair gives me an 8, so there would be 3 8s left, right, when you pair them up. Another way to think about it that might be a little easier is to think root 8 is 8 to the 1/2, right? And if I'm doing that to the 6th, what do you do with a power to a power? Multiply them, so you get 8 cubed. And if you don't happen to know 8 cubed off the top of your head, which I don't, I do know 8 is 2 cubed. And what's 2 cubed? And that I know because I did my powers quiz, right? And that's a 512. So a lot of these you may not be able to do easily like this because you're going to get some ugly decimal. And that's okay. If you have a calculator, use your calculator. All right, and just round however it tells you to round. But if you can be exact like this, you can work your way through it fairly easily. Okay, so when I raise it to the 6th power, I end up getting a 512. I'm going to scroll up so you can see that. So you can see on the setup, I raise the that to the 6th right there, and then what do I do with the angle? I multiply the angle by 6, and that ends up giving me negative 270 and 8 cubed, which is 512. And negative 270, again, is not between 0 and 360, so I add a 360 to it and get to 90. Now, that's trig form. If the problem says write it in trig form, stop. All right, so if it's, and I will say this on the test, I will say write it in trig form sometimes, and sometimes I'll say simplify completely. So if it says trig form, leave it in trig form. Okay? I want that if it says trig form. But if it doesn't say trig form, yeah, if I know what cosine of 90 is, if it's a nice angle, what is cosine at 90? 0, and sine at 90 is 1. So 512 times each of those gives me that. And that is what I would end up doing here. And by the way, you learned a shortcut for this. All right, I don't know if you remember, but what if I factored a 2 out of all of these? Wouldn't I have that? This is what we learned last year. And didn't you learn that 1 minus I squared, if you multiply it all, is negative 2I? And if you didn't memorize that, can you actually square that? Square that times 2, square that, and what does the I squared give you? Which cancels with the positive 1 and leaves you negative 2I. So if that right there, I could rewrite this as 64, and that's the same thing as 1 minus I squared cubed, isn't it? You tracking with me? I tell you what, don't even change it to 64. Leave it as 2 to the 6th. So the inside part gives me negative 2I, that part right there. cubed. So what do I end up with? 3 negatives, right? 2 to the 6th, 2 cubed, 9 2s, and what? An I cubed left over? And what's 2 to the 9th? 5 12. And what's I cubed? Negative I. So you could get there that way, but now you have a way where you don't have to be creative. You don't have to think outside the box. Now all you have to do is go put it in trig form, raise it to a power. That's it. So if I were to ask you something like, hey, this would be a huge number, but if I said, hey, what's 3 minus 4i to the 10th? You don't have to try to get clever and creative anymore. You can just take this, put it in trig form. The magnitude is 5, and you're going to have to find the angle, which is some inverse tangent of that over that, you know, plus I sine inverse tangent of that over that. You can get the angle, right? Yes, no? And then all you have to do is raise it to the 10th. And how do you raise something like that to the 10th? 5 to the 10th on the outside, multiply the angles by 10, which are bound to give you huge numbers, right? And then make sure the angle ends up being between 0 and 360. So you can do these now real quickly, but you have to get them into trig form if you do. And that's the Mobley's theorem for powers. And there's a slight difference in roots, but if you look in your book and you look at their process and their formula they use, it's awful. So I'm going to show you a much better little trick. If you'll follow with me, it's not done this way in the book, but I think you will find it a little bit more simple. So real quickly, let's do a couple of these powers, and then we'll move on to what de Mobley's theorem says about roots. And that'll be it for this unit. We'll review on, we're not here tomorrow, we'll review on Thursday. So we'll answer any questions on the root stuff, maybe give you I'll throw a couple more random things at you that are not new, but just like different ways I might ask a question. And then hopefully we'll do really well on this test. And some of you, you need a boost, you know, and you have a really great, and some of you got a great boost on the vectors test, you got another opportunity for another one. And I kind of do that like this because I always know that the trig tends to work people over, but this gives them a really great opportunity to get back-to-back solid scores in there. And then you never know, you can always drop that trig one if you do well on your exam review, which I'll give you that packet before you go home for Thanksgiving if you want to get a head start on it.
Wait, how many weeks after Thanksgiving is Christmas break?
Not 4. I think I counted 17 class days left.
Yeah, it's like 2 weeks and then exam week.
Yeah, we have, let's say it's 17. So 2, yeah, we have 17 class days counting exams before we go home for Christmas. So it's not much. I mean, there's only 38 total days, and tons of those are weekends, and 9 of those days is Thanksgiving. So it's not much. So you talk about, you take away, I think we're only going to have 2 review days. It's possible we have 3, but I think it's 2. But the upside is they go from Thursday to Monday, so you have the weekend in between. So it's really like you have 4 days if you want to use that. But you're only going to have 2 days to ask me questions. But I'm going to get you your packet well before Thanksgiving. I'll probably give it to you early next week. I've already got it printed, and you can get a head start on it. I am not giving you credit for them this year. And let me just warn you about that. I'm not giving, last year I gave you 60 points for doing it, first semester. We didn't even have an exam last end of the year exam, did we?
No.
Yeah, I don't think we did because of the Corona crud. But we will have an exam this year, obviously. But for the exam packet, I'm not going to give you a 60-point grade on it for a couple reasons. One, tons of people just cheated on it, and they just copy. And I know that happens every year, but it's just a pain to do it. And some people like to get ahead and really check and correct and do it wisely. And I always hold the key out till the end so that people actually do their own work. But I'm tired of battling it. So you won't get that free 60-point boost for doing it. But let me caution you. People that don't do my exam review, like B students, low B students, that don't do my exam review tend to get pummeled on this test. When I say pummeled, 40s and 50s. People that make A's that don't do this exam review tend to make high D's and C's on this test. And it's not because the test is hard. The test is in the review sheet. Okay? It's like, if your test has 50 questions on it, they're in there. I'm pointing because they're in that stack of it, not like I'm pointing at past scores. All right, so they're in that stack, but they're just mixed in with another 200 questions or whatever. So there's a lot of questions in there. It's a little longer than your actual, last year's I think your thing was 24 pages. This year I think it's 33 or something like that. So it's a little longer. It is. But I've actually omitted some stuff too because there was a summer reading section and a lot of those summer reading problems we didn't do. So I've gone through and put omit on a lot of questions. So if you see omit, and I might have missed a couple. So if you see one you're like, I know we didn't do this, tell me and we'll omit that too. So there's some I omitted, but probably not more than a page or so worth. So there's a lot of work on there, but if you do it and check it and correct it, this test is very doable. It is. It is not like I have gone through your old review sheets and thought, ha 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 ha. I mean, I'm going to try to really kill them on this test. I really haven't. Like if you rank problems from 1 to 5, think I've grabbed a whole lot of 2, 3, 4. Probably a whole lot of 3 and some 2 and 4. Okay, so I've left off the child's play because I want to check topics, but it's really more like a regular pre-cal exam, but I'm giving it to you. I'm just hiding it. Not a needle in a haystack, but I don't know, maybe a BB in a snow cone or something, but it's findable. You just got to do the work, all right? It's in there. It's not impossible, but you can find it. You just have to do the work, all right? So let's do a couple of these real quickly. Right here, I said find z to the 6th. Here's your z. So tell me, what do you do to find z to the 6th here? Four to the 6th, which we should know is
4096.
4096. And what? So I'm going to multiply each angle by 6. And what does that give me when I do that? Negative 180. And do I write things negative? No. So I've got cosine. If I add a 360, it's a positive 180 plus I sine positive 180. Now, if I had said leave in trig form, which I did not, I would leave it like that. Because I didn't say leave in trig form, I want to keep simplifying. Because there's a more simple solution than this. So what is the cosine at 180?
Negative 1.
Negative 1. What's the sine at 180? 0. So the I goes away, and I end up getting negative 4096. And that's it for the Mylow's theorem. It's arguably one of the easier theorems we do. You just have to know the rules. Yeah?
So is the 4096, is that standard form?
Yes, because that's technically that plus 0i. That's a plus bi form. And like even my age is like if I say I'm 52, which I'll be able to say for a few more days. If I'm 52,
Mr. Hurry, when's your birthday?
it's coming, man. Go do some research.
Council of the Elders.
Okay, so right here, that complex number form is anything in a plus bi form, and even if it's that simple, it technically is a plus bi form. So yeah, that would be standard form. That would, and some people have different names, but I would probably call it standard form, and that would be trig form. And I will only ask you about those two forms because that's all we're dealing with here. It's not like when there's unit vector form, that's vectors, right? All right, and then what about this? I'll tell you what, we've already done. Well, let's do that because you can see the angles get bigger. So if that's z, what's z to the 7th? 2 to the 7th, which is?
128.
128, great. And what's 225 times 7? Yeah, exactly. So 225 times 7, 35, 17, what, 1575? So I have cosine of 1575 plus I sine 1575. Now that's way too big, right? So what do I got to start subtracting? 360s, or if you know that 2 360s is 720, that's great. Or if 2 720s is 1440, you might be able to jump to that and go, I'm just going to get rid of a 1440. And if you have a calculator, great. If you don't on these, then just do the best you can. And that ends up giving me what, 135? And if this was trig form, I am fine to leave it like that. Or even better, if it's trig form, CIS 135. Those are two great trig forms for z to the 8. But if it's if it's standard form, and you can clean it up, right? So if I'm going to clean this up, what is the cosine at 135?
Negative root 2 over 2.
Negative square root of 2 over 2, so negative root 2 over 2. And sine there, positive root 2 over 2i. And when you multiply that 128 in there, negative 64 root 2, positive 64 I root 2. Not too bad. All right, and then we didn't do one of these yet, so I'm just going to do one for you. And I'm going to point out that on a couple of these, if you're really on your game and you're looking for that angle, you really can probably find the angle without having to pull out your trig, especially when you recognize that I'm moving in a pattern that resembles a unit circle triangle. Like right there, clearly those are unit circle triangle values, right? So where am I if I go over a half and down a lot? Over a little, down a lot?
300.
That's 300, or negative 60, same place, right? So I've got the direction angle. What's the magnitude? 1, because it's a unit circle value, right? So does that make sense? Now, if you don't catch that, you could say magnitude is that squared plus that squared under the radical, and you'll get a 1. And if you don't catch the angle, you could say inverse tan of that over that, which gives me inverse tan of negative 3, which is negative 60. You can do those things, but hopefully you can shortcut this process and just recognize that it is a unit circle value and jump right there. So I'm hoping you go, oh, well, that complex number has a magnitude of 1, and it's just CIS, negative 60 degrees, or like you said, 300. That is what I want to raise to the 8th. So how do I raise that to the 8th? 1 to the 8th, which is just 1 again, and that times 8, which is negative 480. Am I allowed to leave it as negative 480?
No.
If I add a 360, I get negative 120. If I add another 360, I get 240, and that's what I like, right? So 1, you don't really need the 1 at this point, CIS 240. And that would be trig form. And it says you must put the complex number into trig form to be able to apply de Moivre's theorem. That's not what actually was doing. But anyway, I did put it into trig form to apply de Moivre's. If it's in trig form and I can go further, I will, unless it says leave in trig form. Now, if it does say leave in trig form, what are you going to have to do to this? Cosine of 240, which is what? Yeah, you've got to know your unit circle, right? 240. What's cosine there? Negative 1/2. What's sine of 240?
Negative root 3 over 2.
Negative square root of 3 over 2, and don't forget your I. So believe it or not, that thing to the 8th ends up looking like that. And if you're ever thinking, wait a minute, are there some patterns there? There are. They are not worth learning because I once spent hours trying to figure out some patterns and some tricks 2 decades ago. And I noticed them, but they were not worth it. As little as these show up and as little work as it is to get there. All right, what about this thing? Now, again, I'm raising it to the 10th. We could use those tricks that I learned before, right? By maybe squaring it and getting that answer and then raising it to the 5th. And I probably wouldn't hold that against you on a test unless it says use de Moivre's theorem. And if it says that, you've got to use it. So do I know a magnitude here? Those are not unit circle values. So can I find a magnitude? What is it?
Root 2.
Root 2, right? Because square that, square the 1 out in front, and you get, add them together, you get 2, so root 2. So I have root 2, and then what is the angle there? Now think, it's not a unit circle value, but what am I doing if I go left? Think about it. If I go left and up the same amount, what angle is that? 135, right? Does that make sense?
Yeah.
So take advantage of that. You don't always have to use inverse tan. If you think about where the angle is, it makes your life a little easier. So if that's this part right here, then just raise that to the 10th. So what's root 2 to the 10th the same as? 2 to the 5th, good, and 2 to the 5th is?
32.
32, so I'm basically raising it to the 10th to get that, and then what do I get for the angle? Times 10, so 1350. And then again, I'm going to have to subtract off 360, 360, another 360. So I'm going to just take off a 720, and that gets me to 630. And then I'm going to subtract another 360, and that gets me to 270, right? So that's the same thing as 32 CIS 270. And if I said trig form, you're good. But if I don't, then you want to keep going. So how would you keep going? What is cosine of 270? Straight down, what is it? What? Cosine of 270? Zero. What's sine of 270? -1, but with the I, right? Cosine 270 plus I sine 270. So what does that end up giving me? So I think you can do these. They're not that bad. Hopefully you're not going to be intimidated when they put it without trig form, but that's De Moivre's theorem, and it always works through trig form. All right, now, I want to talk about De Moivre's theorem with roots. Now, technically, it's the exact same formula. But when you look up in the book and you look up De Moivre's theorem with radicals, or how to take the roots of complex numbers, they give you some awful formula. And the formula makes great sense. And I used to teach it from the formula, and everybody got pounded on this. And then I started teaching it a different way, and everybody started doing really well. So I'm just going to assume from my small sample study there that my way works a little bit better than the ugly book definition. Okay? And I think you'll agree, because it's essentially De Moivre's theorem with a small thing added on. Now, here's the thing that's the difference. I don't know if you know this, but when I cube a number, okay, like, how do I say this? If I have something like x equals 2, and I cube both sides, I get what? One answer. However, if I have something like x cubed, and I cube root both sides, I get more than one answer. Now, you may not know that. You do know it with squares, right? If I gave you something like this and I said square root both sides, you know that you get 2 answers. What you might not know, that when I cube root this, I get 3 answers. Now you may go, no you don't, you get x equals 2. Let's think about it. And I think you actually know enough to believe this. It's just very easy to forget this. So if I really said x cubed equals 8, I could try to cube root both sides, and that would give me the real solution. But couldn't I also solve like this? And then factor it? And how do you factor a difference of 2 cubes? Binomial? Trinomial. Do you remember this? You should. X squared, one of the 2's, 2 squared. Whatever I put there and there goes in the middle. Same sign, opposite sign, always positive. Now, here is your x equal 2. That's the number everybody remembers. But the reality is, on a cube root of a number, when I solve a cube root, I get 2 more answers. They're just not pretty, are they? But they're going to end up being imaginary solutions. And I want to show you something about these imaginary solutions. Check them out. Negative b plus or minus b squared minus 4ac, all of that over 2a. And check out what I get here. Negative 2 plus or minus. What's 4 minus 16? Negative 12, which is what? 2i root 3. And what is all of that over a 2? Negative 1 plus or minus I root 3. Now let me ask you a question. X equals 2, if I was sketching that on a real imaginary plane, real imaginary, how would I graph 2? Right there. You with me? How do I graph negative 1 plus I root 3? Negative 1 plus, and what is root 3 about?
Near 2 or something.
It's about 1.7-ish. I don't know if you know that. You ought to know that. Root 2 is about 1.4. Root 3 is about 1.7. It's good information to know when it comes to approximating stuff. So left, up a root 3. Puts me about right there. And then left, down a root 3. Puts me about right there. Now I want you to see something. That that, and that all happen to be 120 degrees apart. And these magnitudes are all 2. Check out the magnitude of that. Square the 1, square the root 3, add 1 and 3 and square root it, and you get 2. The same magnitude you got here. So what happens is the roots of the number 8, there's 3 of them, and they all are split evenly around a kind of a unit circle. They're always a certain number of degrees apart from each other, and if there's 3 roots, they're 100 degrees apart. 120 degrees apart. What do you think if there are 4 roots?
90.
They're 90. What if there's 6?
60.
There's 60. What if there's 10?
36.
There's 36 apart, right? I was about to say 30. What if there are 2?
180.
There's 108. They're 180 apart. I think of this x squared equals 4. When you square root it, you get what? 2 and negative 2. 2, negative 2. 180 degrees apart. Same magnitude away from the origin. That's the nature of complex numbers. But you don't have, and we're not always going to be able to factor them because we don't have factoring rules for every kind of complex number. However, we can find their roots using de Moivre's theorem, and we can use it to find the first root, like the 2. And if I can use it to find the 2, I can take that complex number and just add however many degrees it is apart to find the other complex numbers. I'm going to show you how to do that, but the key again is recognizing if you say cube roots of a number, there's 3 of them. De Moivre's is going to help you find the first, but if you know there's 3, how many degrees apart are they? 120. Right here it says find the 4 fourth roots of that. I know that there are 4 of them. De Moivre's is going to help you find the first. How many degrees apart are the other ones going to be? 90 degrees apart. And no matter what the situation is, that's how this is going to play out. Now the only difference is de Moivre's root, this is the only thing you got to change, and it's not really a change. So you know that de Moivre's theorem says if you have a complex number, this is de Moivre's, right? It says, if you raise it to a power, what do? Raise the absolute value to the power and multiply the theta by n. All right, let's think about that. N. If I'm doing a root, if I'm doing like a 3rd root or a 5th root or a 4th root, isn't a root the same thing as a fractional exponent? Right? So with that in mind, what do you think I do with the magnitude? According to this, I just raise it to that power. So what would you do with this? Raise it to 1 over n, which is what? The nth root. Are you with me? And then what did you do here with the theta? You multiplied it by the power. What do you think you're going to do here to the theta? Multiply it by the power, which is 1 over n, which ends up doing what? Dividing. Are you seeing that? Now here's the difference. That is what you do to find the first one. But there are this many of them. So what you have to do is find the first, and the second, and the third, all the way down to the nth. But guess what? Each one of these other ones is going to be just like this, except you're just going to add those extra degrees they are apart. So if it was a 4th root, stay with me on this. If it's a 4th root, how many degrees apart are they? 90. So from here, I'm going to take whatever I had, plus 90, plus 90, plus 90. If it's a cube root, how many degrees apart are they? 120. Take whatever you have here, plus 120, plus 120. And the magnitude, the way you find magnitude is the same, but instead of raising it to the n, I'm going to basically nth root it because that's raising it to the 1 over n. And instead of multiplying by n to get the only power, I'm going to multiply by 1 over n, which is divide by n to get the first one. So let's try this. It says find the fourth roots of 8 plus, find the 4 fourth roots of 8 plus 8i root 3. Now the first thing again is I can't use de Moivre's when it's in a plus bi form, can I? Or standard form. So what do I have to do? All right, so put it in trig form. So how do I put that in trig form? What do I need? I need the absolute value, which is 8 squared plus 8 root 3 squared, which is what? 8 squared times 3? Are y'all with me on that? So what does that give me? I think it gives me 2, and then square root it. So I get 64 plus 64 times 3, which is what? 192, 256, and what's the root of 256? 16. And you probably have a calculator for something like this, but if you didn't, hopefully you'd be able to get that. At the bare minimum, you could simplify, or you could be creative right here. Isn't that the same thing as 4 8 squareds? Take out of 2, take out of 8, 16. So I've got my magnitude. Awesome. Now, what's the angle if I go to the right 8 and then down an 8 root 3? Does that look familiar to you? Oh, up 8 root 3. What if I go to the right 8 and then up 8 root 3? What kind of triangle is that when you go A root 3? 60 degree, right? You learn that, right? 1A, 2A, A root 3. So if I go 8 root 3, that's a 60 degree angle. I don't need the inverse trig definition for that. That's 60 degrees. So cosine 60 plus I sine 60. But if you want to use trig, knock yourself out. Inverse tangent of that over that gives me inverse tangent of root 3, 60. Now, once I'm here, let's apply de Moivre's. So here we go. So that's my complex number. How do I do the 4 fourth roots? What do I do for the first one? I raise that to the 1/4 or the 4th root, which gives me, I'm going to write that out just to point out for your notes. 4th root of that, and then what do I do for the angle? Angle divided by 4, plus I sine angle divided by 4. So for the first one, that simplifies to 2 CIS 15. This is where you're going to really like CIS, because I'm going to have to write this out 4 times, the 4 different ones. Now, once I have the first one, if there's 4 roots, how many degrees apart are they? Because they're always evenly spaced, right? So if they're 90 degrees apart, for the second one, add 90. For the third one, add 90. For the fourth one, add 90. And by the way, if you add another 90, what do you get? And what's 375 the same as? And you're right back where you started. Are you with me? And this beats the crap out of the formula. You look it up in your book and you'll go, oh yeah, that does beat the crap out of it. Okay? So these are not hard to do. It's really de Moivre's theorem, but you have to remember the other ones. If all you do is write this first one down, you've done 1/4 of the work. Ironically, you've done most of the work, but you've only given me 1/4 the answer. So don't let that happen to you. 9 minutes? What about this next one? Help me out. How do I put that in trig form? I'm looking for the 3 cube roots. So the magnitude is what? Looks like unit circle, right? So 1 is the magnitude. CIS, what's the angle there? Negative root 2 over 2, down root 2 over 2. 225. Okay, here we go. I want the 3 cube roots. So how do I find my first one? I take the cube root of the 1, and then what do I do with my angle? Divide by 3, and what's 225 over a 3? 75. And I don't need that 1 out there, so just CIS 75. Now that's the first one. How many total do I have? 3. So now I need the second one and the third one. What's this? What do I add to this one to get to the second one? 120. So 120 added on that is 195. And how do I find the third one? Add another 120, which is what, 315? And you might want to just double check. What happens, just to make sure you've added right, what happens when I add another 120? 435. And what's 435 the same as? 75, and I'm back to where I started. If you want to double check your math, because very easily people get off sometimes on this. They get 10 off and they miss all the angles, which I'm not going to crush you for that. If I see that that's a careless error, you'll probably just get dotted. But anyway, it's worth to me a little check there. All right, what about, there's one on here. Okay, here we go. Find the 3 cube roots of unity. I remember the first time I saw that, I was like, what the heck? And then I went, wait a minute. Unity, unit. What do you think they're talking about? 1. That's just their way of trying to screw you over. I guess mine too, then, since I use it. But that's a math team question that shows up. Find the 5th roots of unity. And you're like, I don't know, togetherness? I mean, you feel like you have to really respond in a fancy way. But no, roots of unity means the roots of the number 1. It's that unit digit. So I need to write 1 as a complex number. So how do you write the number 1? How do you write 1 as a complex number? The magnitude, because 1 is to the right, isn't it? If you think about the number 1, isn't it 1 unit to the right? So how do you write that as in trig form? So magnitude is 1, CIS, what's the angle? 0. It's almost too basic, right? So what do you do for the first root? So that's just the conversion. So for the first one, what do? I take the cube root of 1, and then what? Divide the angle by 3. And what do I end up with? The exact same thing. So to me, if you remember that, the roots of unity are a little bit easier because the first one is the number 1, which makes sense, right? Because if I square root or cube root or 5th root or 10th root the number 1, what do I always get? 1. So you can always start with 1, which makes it really nice, but you ought to have it in trig form. And then what separates that between the other 3? 120 degrees. So the second one, CIS 120. Third one, CIS 240. And again, if I add another 120, I get 360, which puts me back to 0. And if I said leave it in trig form, you'd leave it. Now, could I simplify each of these? Sure. And if you could, you would, unless it says trig form. And on a lot of these, I say leave it in trig form because I don't want you to bother. To me, this test is not about do you know the unit circle, although you will have to know it a couple times. It's not about, I'm not going to dot you on every problem because your unit circle skills are struggling. All right, how about another one? What's the 5? I'll tell you what, there's a better one than that. What about maybe not. I'll tell you what, let's change this one. 5 5th roots, not 32, but negative 32. Ooh. How do I write negative 32 as a complex number? What's the magnitude? What's the absolute value? 32. Don't forget that we know that, right? I'll tell you what, let's make it even harder. 32, negative 32i. Now, how would you sketch or graph negative 32i? Down 32. What's the absolute value? What is the distance from negative 32i to the origin? 32, right? Now, if I want to write this in a plus bi form and use my definition, I can, but what do I end up getting? The square root of 32 squared, which is 32. So I know the magnitude's 32. What is the angle if I'm down at negative 32i?
270 or negative 90.
270 or negative 90. Which one do you want to use? I kind of like using 270 on this one because if I'm going to be, but you could use negative 90, but I'm going to be adding, and I'd always have to convert the negative. But if I add to 270, but let's see, actually, I like using the positive one because we're going to divide it by 5. It's going to make it small, and then we can just add it back. It'll never go over 360. If you go negative and divide it by 5, it's negative, and you're going to end up having to change one of those negatives back to a positive. You'll get the same numbers either way. So the angle is, I'm going to go with 270. So that is what this is. Is everybody with me on that? So think about the graph. Now, would you have had a lot of luck if you did inverse tangent to find your angle? Inverse tangent of negative 32 over 0. What does that tell you? The inverse tangent of an undefined value? You can't do the math on that, but you could go, oh wait, where is tangent undefined? Up or down, right? Oh, but this one's down, so it must be negative 90 or 270. But that's what I'm saying. If you think, I think you're going to be better off in most of these cases. So what is your first of the 5 fifth roots?
2 CIS 54.
So fifth root of 32, which ends up being 2, CIS of 270 over 5. So let's clean that up. We get 2 CIS of 54 degrees. You tracking? Now, there's 5 of these roots. How many degrees are between each one? That's right, because 5 into 360 gives me 72 degrees. So I've got to add, for the second one, 2 CIS, add a 72, which gives me 126. For the third one, 2 CIS, add a 72, gives me 198. For the fourth one, 2 CIS, add a 72, gives me 270. And for the fifth one, 2 CIS, add a 72, 342. And if I were to add another 72, that would give me 414, which is 54 degrees over. When I subtract 360, and that checks. Y'all seeing this? That's it. You've got tonight, Wednesday night, Thursday night, prepare for this test. The better you do, the easier the grade. So help me help you.